I've been involved with RecSys for a long time. This is my 11th RecSys. I attended the first 6, so I was very involved at the beginning. And also, other fun facts is when I transitioned from academia to industry, I did find my job here in RecSys in Barcelona, 2010. That's where I literally started my conversations with Netflix, and then led me to Netflix and to many other things. And I'm looking around, and I see a lot of people that some of you have been an intern with me and then went to Netflix and followed sort of like similar steps. So really happy to be here. Also, I love this community because of how it intersects industry, academia, practitioners, also people that care about algorithms, but product and users and psychology. So I'm going to be giving you a very personal overview of the history of recommender systems and how we got here. But I'm really, really interested in also looking forward and looking at the future and trying to give you my personal vision from my vantage point of like where recommender systems are going. So the 3 parts of this talk is how we got here, then recommending in the age of GenAI, which is the present, and then what's coming, what's next. So how we got here, how many of you recognize the screenshot? Oh, not that many people, okay. Oh, wow. So this is MovieLens. This is version 01, I think. It was published in 1997. And Joe Constant, who I heard couldn't make it this year, and late John Riddle and the rest of the MovieLens team at University of Minnesota started this whole field. I think they could be called the godfathers of recommender systems. And that's why the first RecSys conference was actually held in Minneapolis. And I think next year, we're also going back to Minneapolis, right? So this was the first early days, 1997. But if we go back, and I'm intertwining, and I'm going to be intertwining and connecting the history of recommender systems with the history of AI, right? So going back to the 50s, when the artificial intelligence term was coined in the famous Dartmouth Symposium, that was almost the same year that Rosenblatt published his perceptron paper, right? So neural nets were invented. And for a few years, it seemed like that was the way that AI was going, until Minsky published his book and proved that neural networks would never work. And that led to the first AI winter around 1974 to the 80s. In the 80s, people went back to expert systems. And I say went back because expert systems had already been tried in the 50s. And in fact, some of the early chatbots like Eliza were expert systems. But expert systems were something that became, again, fashionable in the 80s for a little while, until people saw that they were brittle, they couldn't scale, they were probably not the way forward. And from 1987 to 1993, there's the second AI winter. MovieLens V0, the data set, and the first paper was published in 1997, as I mentioned. And that could probably be sort of like the starting of the recommender system as a field, right? Going forward, 2006 to 2009, the Netflix prize, we'll talk quite a bit about that. 2007, on the heels of sort of like the Netflix prize being announced, that's what this conference got started. Fast forward, deep learning, 2011, roughly, that's when deep learning sort of like started gaining momentum. 2012 is the famous Google paper on finding cats. 2012 was also the year where we published the Netflix Beyond the 5 Stars, a little bit sort of like going beyond sort of like what the Netflix prize had presented. 2016, deep learning for YouTube recommendations was a big hit at the RecSys conference. That's the same year that AlphaGo beat Lee Sedol, the famous Go player. And then 2018, that's when the attention is all you need paper, transformers came to be. And I'm going to leave that second part, that's sort of like the second part that we'll get to. But this is a little bit sort of like a history of AI intertwined with the history of recommender systems. Now, let's go to the Netflix prize, because I think it's something that I was closely involved with, and also something that sort of like was a turning point for this community. I'm going to ask the question again. How many of you participated in the Netflix prize? Okay, so maybe like 4 or 5 people only. So they're making us feel very old now, right? So the Netflix prize from 2006 to 2009, that was before Kaggle and all this other sort of like ML competitions, and it was a big deal, right? It was the proxy, or the goal was to find high quality recommendations, and the proxy question was root mean square error. If you were able to increase 10%, then you would get $1 million. That was a huge deal, and I know there was thousands of people, and there was a lot of interest, and Yehuda Koren, who's also very connected to this community, was the leader of one of the teams which merged at the end and won the prize. And the final prize was an ensemble. You know, things are usually always won by an ensemble. It's like in machine learning, combining things usually beats a single approach. And even in now LLMs, when you do mixture of experts, for example, you're kind of doing an ensemble at the end. But it was 104 different models merged through a neural network. So the final layer was a neural network, which is also interesting. And the main 2 algorithms were matrix factorization, SVD, a variation of that, and then restricted Boltzmann machines, which is also a neural network. Those were the 2 main models, but there were 104. We took that to Netflix, and we tried to see like how we could fit it into the product. And the reality is we did not productionize the 104 models. It was way too complicated, too slow, it didn't scale. And more importantly, also, while we were doing that, we realized that the proxy question, the objective of the what we were asking in the Netflix prize was probably not the right one, right? Optimizing for rating and RMSE was not the right thing. I will say we did productionize both SVD and restricted Boltzmann machines that went into product that early on were part of the recommender system at Netflix. In fact, they were the first ML algorithm that went into the product at Netflix, but the other 102 did not make it in. So at that time, we didn't even talk about machine learning. We talked about algorithms. In fact, the team that I started at Netflix was called Algorithms Engineering, because machine learning was like, oh, whoa, it's probably too much. And now we've gone from algorithms to machine learning to AI, and that's part of sort of like what I will talk in this presentation. And this is a slide that we prepared with my good friend Justin Basilico, who's also well known in this community, about like how do we think about what is an algorithm, how do we do machine learning on recommender systems. This is the most basic personalized recommender system that you can build. It has 2 features, therefore 2 parameters, right? We've gone from 2 parameters to trillions of parameters, but this has 2 parameters, and it's a linear model. And it uses 2 features. It uses popularity, and it uses the predicted rating. The predicted rating, which you can take from the Netflix prize, so you have it already there for free. And then the goal of what you need to do is estimate the 2 parameters, which in this case are W1 and W2. How do you do that? You estimate it from data. You basically have a lot of data from consumers. You pour all of that into machine learning algorithm, and then you learn the parameters. If you use a linear model, you can do linear regression, which is probably not going to work very well. And you can go from there to logistic regression. You can make algorithms more complicated, and of course, you can use neural networks, you can use whatever. It all depends on how many features you have and how you complicate your algorithm. And in fact, that's the way we did machine learning in the old days, right? We did that by basically adding more features and making the algorithm more complicated. And feature engineering required a lot of domain knowledge. You had to know like what feature makes sense. I talked about popularity and predictive rating. That actually makes sense. What else could you add? oh, what about the genre of the movie? What about something else? In the case of Quora, where I led the engineering team, and we did a lot of machine learning on questions and answers, one of the first algorithms that I faced was how to rank an answer given a question. I thought that was fascinating, right? Because if you are asked, like, how do you rank a bunch of answers giving a question, it's not easy. Like, I had never thought about it. So we had to really engage with experts. So we talked to editors, journalists, say, how would you say that this answer is better than this other answer? And they told us things like, oh, an answer needs to be truthful, and it needs to be reusable, it needs to be well formatted. Of course, you have to write it well, and it can't be too long, it needs to be a certain length. All of those things were then turned into features that were learned in the same way that I mentioned before, right? So that's the old way of doing machine learning, which, by the way, I'm just saying old, kind of tongue-in-cheek, because we still do some of that, of course. And at one point, the recommender problem evolved, and I used this diagram to sort of like illustrate the difference of like how we started in the Netflix prize by point-wise predicting a rating. And then we realized, well, it's not really about predicting rating because it's more about ranking things. So we went to the two-dimensional problem of ranking. And then later on, we started talking about page optimization. In fact, it's not only a ranking. Yes, you might have a single feed of things, but the reality is you have a whole page and a whole surface of things that are competing for attention, and you want to optimize the whole page. And then, of course, there was context awareness, like that page actually changes. It depends on the device, it depends on the location, the time of the day, and that adds more and more dimensions, right? And I'm pointing out to two things here. This blog post, which is still up and was pretty popular, which we wrote about Netflix recommendations beyond the 5 stars, and we talk about the ranking problem and about why implicit ratings are better than explicit ratings. That's another change that happened right around there. And then the multiverse recommendation paper, which we published at Barcelona RecSys 2010. It's my most highly cited paper from RecSys. So that's also a context-aware approach that we published in 2010. Okay. Now, at that point, we went from algorithms to deep learning, right? And that's when, as I mentioned, around 2011 to 2016, with the Google YouTube paper, deep learning came about. And in case you're not familiar with it, this is the most popular, straightforward approach to using deep learning in recommender systems, the two-tower model, where you basically have embeddings for the user, embeddings for the items, and then you use the dot product of those embeddings to basically find a recommendation. Of course, there's many variations over this and much better, and there's wide and deep networks and a lot of things you can do. But this is already a good starting point. And that kind of like made us revisit the recommender problem again. And in fact, even before the YouTube paper, in 2014, we were already experimenting with distributed neural networks. It was clear that deep learning was kind of like going to make a difference in recommender systems. In 2016, I had this tutorial, the recommender problem revisited, which we then did with Bamshad again in KDD in 2017, and talked about sort of like how deep learning was already impacting the recommender systems. Now, I'll do a little bit of a geeky rabbit hole here, and I'll say, what about deep learning? I mean, deep learning came about, and the promise was, you don't need to do all that fancy feature engineering, well, fancy or costly feature engineering that requires domain knowledge, because deep learning is going to learn the representation for you, right? It's representation learning. You just pour the data in, you basically optimize a function, and you'll get the representation for free, like embeddings and so on. So you don't really need to know domain knowledge. Now, interestingly, I think there's a very interesting connection between deep learning and what we were already doing in recommender systems. In fact, in recommender systems, we had already been using this combination of supervised and unsupervised learning. If you think about it, even matrix factorization by itself is in a way a combination of supervised and unsupervised. You do unsupervised learning because you basically are reducing the dimensionality of the space like PCA, but you also have labels, which are whatever implicit ratings or explicit ratings, and you're doing a form of supervision in the whole process. So there were a lot of, before deep learning, a lot of ways that we were already combining supervised and unsupervised learning. And here are a couple of examples. Even with clustering, we used a lot of clustering approaches at Netflix back in that day. And they're still useful in many ways. Even in the world of LLMs, people are using clusters. Now, maybe the main transition here, because of deep learning, was into self-supervision, right? Which is kind of the same idea. You combine supervised and unsupervised, but in a way that you don't really need the explicit labels because you have the labels in the input itself. You have an input where you're basically hiding parts of the input, and the parts that you're hiding are the parts that you're trying to predict. And this is the famous Jan LeCun multi-layer cake, where he talks about the different parts of like how do you use machine learning. And it's really fascinating. This version is from 2019, but he's basically already predicting what we do with LLMs today, right? There's this sort of like the unsupervised, self-supervised pre-training. There's the supervised part, which is usually the fine-tuning, the SFT, and then the reinforcement learning, which is the kind of like the icing on the cake that is done at the end to improve the models. So even though all these things are revolutions, you can almost consider them evolutions of the same kind of approach, right? Now, I'm going to pause here and say it's not only about algorithms. There's a lot of things that matter besides the algorithm. And I'm going to summarize them into these three, right? The user experience, the design matters a lot. This is here on your left, you have a screen capture of the early days recommender system on Netflix. And the point here is there's so many explanations happening here. So you have the estimated rating where we were telling you that you had added this movie to your instant queue. We're telling you this was based on your interest in Iron Man and X-Men. We were telling you the stars of the movie, the director. All of this are explanations and sort of like part of the UX design that we realize in many cases they matter more than the algorithm itself, right? How do you present it? How do you explain it? Was extremely important, and also was part of why we ended up abandoning the stars and going to thumbs up, thumbs down at some point, because that also connected to some of the things we found through user experience and through sort of like A/B testing and analysis of like how users were responding. Now, domain knowledge is also important. Even if deep learning does a lot of the representation learning for you, it's important to understand your domain, particularly if you're dealing with specific domains like healthcare, which, as was mentioned in the introduction, I worked on for many years, or domains that have sort of like some really clear constraints and specific requirements. And the third one, evaluations and metrics. That's key. You have to have a way to say if something works or doesn't work. Evaluations and metrics, usually the approach that we always use and the one that I recommend is like you have to have offline and online. You have to find ways to iterate quickly. Offline, have good proxies that map to what you are going to see in the product. Now, finding those proxies is not always easy because what you care about online in an A/B test, it's even hard to measure because you usually care about long-term retention and satisfaction of your users, which you would need to run an A/B test for maybe 6 months, a year. It's very costly. So you have to find always ways to sort of like map your offline metrics with your online metrics that are short-term and then your long-term. And by the way, there's I think a very important paper in recommender systems too that was published in KDD, I want to say 2020, 21, also by the YouTube team, about what they found out was the best offline metric that mapped to online user satisfaction in the long term. And I always ask this question, and I think it's fascinating because it was a poster, by the way, so I talked to the authors in the poster, and they told me that the one they had found out that was sort of like the best correlated, not even correlated, they did a causal analysis. So there was a causal connection between the diversity of content that was consumed and the long-term satisfaction of the user. So you think about it, it's really important, it's a really key finding that you don't want to engage people only in consuming the same content. You want them to sort of like have diversity and to engage them in different contexts. That will contribute to their long-term satisfaction. Okay, so let's get to today. As Bill Gates said in his note in, I think, October 2023, the age of AI has begun, right? And of course, this has been all triggered by transformers, LLMs, GenAI, and all that. On the right, you have the famous attention is all you need paper. On the left, you have, this is a plot from a paper that I have on transformers, where I went back for the past 5 years and analyzed sort of like what were the publications about transformer models. And the colors are the families of the transformers, and the y-axis is the number of parameters, which started around 100 million, and now we're over a trillion. And it's now at this point good to remember the first algorithm that I introduced had 2 parameters. Remember, popularity and predicted rating. So that's why I said we went from 2 to trillions of parameters. All those parameters need to be learned from the data. And I also want to point out this has had a tremendous effect also in research community. As Maria mentioned, I have continued publishing, and I was shocked to see what happened to my citations. So I consider that I've had sort of like some impactful research in recommender systems, but 2024, 2025, what happened there is I actually publish, and I say quote, quote, publish, because these 3 publications are just an archive. They're not even published, so they're not peer-reviewed. And the first one is a survey on large language models, which I think is very good, and we have sort of like Mikolov and Richard Socher and sort of like a good set of co-authors on large language models. And the second one is about prompt design and engineering, and the third one is the catalog I mentioned on transformer models. But the fact that GenAI and LLMs and transformers are getting so much attention, even in research too, is really fascinating and worth highlighting. Okay, so yes, GenAI has already changed and quote unquote transform recommender systems, right? I have 3 examples here, all from Google, of course, for obvious reasons, but I think they kind of like highlight like some of the things that are happening. So LLMs, for example, for understanding user preferences is a whole trend and an area that in the past, not many, like couple of years, has gained a lot of attention using approaches like generative retrieval, and then using transformers, not even LLMs, directly for recommendations that are based on some form of content that can be processed, whether it's video, whether it's music, like in this case of transformers in music recommendation, where you can use transformers. And as we should draw a distinction, not all transformers are LLMs. And in fact, not all LLMs are transformers. And there's also diffusion models that are kind of be combined in different ways with transformers. But this whole area, which is to some extent, I mean, I use the term GenAI because it's the best one that we have, but it's not entirely always about generating content. LLMs plus diffusion models plus everything that leads to from transformers and the combination has had a huge impact. Now, I want to go back to what I said before. Even in this day and age, UX, domain knowledge, and evaluation metrics matter. Now, they do matter in a slightly different way or somewhat different way. In many cases, the UX right now has become the AI, or the AI and the UX are so intertwined, and they're so much in the user and the consumer's face, right? In the old days, we were kind of hiding the AI machine learning algorithm behind the scenes, and the UX was all about how to present the explanations and all of that. Now, the UX can be the AI itself, or quote unquote a chatbot, right? Or something like it. In the case of domain knowledge, we still need specialized domain knowledge, but it is also true that the pre-trained foundation models have a lot of domain knowledge themselves, and out of the box, they might know more about medicine than most doctors, right? So they do have a lot of domain knowledge. And evaluation and metrics continue to be key. In fact, they become maybe even more key. That's the one aspect that has been increasingly more and more important. Evaluating GenAI is very key, very important. It does require domain knowledge, so it connects to the second aspect. And it also, in many cases, particularly when you do online evaluation, it does connect to the UX, because you need to be able to capture the right feedback loop from the user in order to make that evaluation happen. So at this point, let's pray to the gods of demos, and I'm going to start with my first live demo. So we're going to try a basic LLM, and we're going to try a very basic recommendation. So I'm going to tell Gemini 4 shows that I liked from Netflix. I'm going to ask it to give me a recommendation. The fun part about this demo is that it's always different. So that's why I like doing it. And if it doesn't work, we'll just blame the Wi-Fi. So a key aspect here that while it's Gemini Pro is thinking, if you read the way that it's sort of like going about, it's extremely, it's very good. I mean, as a recommender system researcher, when I read these explanations, first it says, well, I'm going to pinpoint the show attributes. I'm now identifying common themes. They're all complex dramas, some with dark humor. And then I'm going to uncover common threads. I'm zeroing out on the common threads. I'm synthesizing recommending strategy, crafting the recommendation categories, crafting recommending categories. And here's the answer. So it's giving me 3 answers in this case. Ozark, which I've watched and really liked. Mindhunter, which I haven't watched, actually. Serial killers with 2 FBI agents, criminal profiling. I could see myself watching. Okay, Barry says it's good, so I'm gonna trust Barry. And then Narcos, which I have watched and I like. Now, every time you put this prompt, you'll get a different answer, which is also the fun part. But you already get the ideas. Like this LLMs out of the box are already, first of all, they have domain knowledge, but also they have the insight of sort of like doing this reasoning that gets you to sort of like very good results. Oh, by the way, I think it actually gave me different categories with different recommendations. The first one was about anti-heroes and criminal underworlds. The second one is dark comedy and dysfunctional families. And then gritty character-driven dramas, which actually, yeah, I like all these shows. So it's a pretty good recommendation. Now, of course, this is a very obvious application. Let's make it a little bit more fun and also more useful. So now, I'm going to start with this prompt, which I'm going to start with the idea that the LLM doesn't know anything about me. So I'm going to say, let's play a game. Ask me 5 yes or no questions, and then recommend 5 music artists I will like. So I'm starting from a blank sheet here, and I'm going to ask the LLM to basically do some user preference elicitation. Now, the reasoning is usually also very interesting. it's, you see, it's designing the recommendation flow. I'm now diving into specifics of the question-answer flow, refining the question sequence. I'm focusing on the first question to build a decision tree. So it's building a decision tree, and it's actually also mapping subgenders and preferences, and refining the questioning logic, expanding questioning strategies, finalizing the recommendation, structuring recommendation engine, all of that out of that simple prompt. I didn't do anything else. This is just a Gemini out of the box, and I encourage you to try it out. Okay, here's the first question. Do you generally prefer music that was made before the year 2000? That's a tricky question. Okay, let me actually, I'm gonna try to mess with it. I'm gonna say sometimes. I know. Let's see what it does. Sometimes. Now, it says, oh, I'm understanding the nuance. It means you have a broad taste. We'll count that as a flexible no. Okay, well, sure. Let's move on. Is a strong distorted guitar a sound you often enjoy in a song? Yeah, let's say yes. Considering user preferences, analyzing user's profile. Okay, it already has a user profile for me. That's interesting with 2 questions. Is a catchy sing-along chorus important for your enjoyment of a song? Should I say no? Not really, yeah, no. Okay. Updating profile. So I haven't asked it or told it to do a user profile or anything like that. Does the music you enjoy often have a complex or unconventional rhythm? Yes. Revising the profile, narrowing the focus. You can always sort of like go into the details. I've analyzed the responses to build a solid bass profile, consistent yes to complex rhythms and guitar. Okay, excellent. This is the most telling answer yet. You have a taste for music that's technically demanding. Yeah, that's true. Final question. Are you okay with vocals that are screamed or harsh in addition to clean singing? Barry says no. No, yes? What should I say? Okay, well, I'll go with no. No yelling. Okay, so now let's see what it comes up with. And of course, this is a fun game to play. You can play it many times. You'll get different recommendations. I'm usually very surprised by the quality of the recommendations I get after this 5. Okay, 5 music artists that you will likely enjoy. Tool, the quintessential band for your taste. They're famous for their use of extremely complex time signatures. Wow. Heavy guitar riffs, long structures. Does anyone know Tool? Yeah, it's good? Okay. King Crimson, Animal as Leaders, Russian Circles, and Carnival. So these are 5 recommendations. I mean, obviously I know King Crimson, but the other ones are a little bit off for my taste. So I think that's because I answer no to yelling, maybe. but it's really interesting that you will get really interesting recommendations with only 5 questions. And the other thing that I wanted to illustrate here is the fact that you can start with no prior user profile and have the LLM itself sort of like engage in this user elicitation game. Okay, so there's many approaches to using LLMs in the, as I mentioned in the past, just 3 years. It's hard when you think about time, things move so far. Like, yeah, it's only been 3 years. But there's already so many papers and so many approaches. I like this diagram from the STAR paper from Etchi, who should be here in the audience somewhere, and the team at Google, DeepMind, where he kind of like they classify different approaches to LLMs, right? You can use it in a prompt, which is what I did. And you can use it in a prompt even without user history. You can use user item interactions and feed that as user history. You can also use LLMs to create semantic features and whether it's semantic IDs or some kind of embeddings, and then combine them with user interactions. And in their approach, they actually use two different LLMs, right? So the first one is to create the semantic feature, which they combine with the traditional collaborative filtering features, and then they pass the candidates onto a second LLM that does the ranking. So you can use LLMs not only once, but several times in different ways and in different approaches. And many of these approaches actually show competitive or even better results than traditional collaborative filtering approaches. So with that, I'm coming to the last section about like what's next. So this is a screenshot from a startup in Silicon Valley. It's called Fable. I don't even know them, but I've read about them, and they're interesting because their whole proposition is like it's like the Netflix for generative content. So basically, it's not like the content is fixed. The content gets generated in a personalized way for every user as we go. So this is like kind of like the last step of personalization. It's not about recommending you content. It's about generating content that is personalized to you on the fly based on your preferences. Now, forward-looking, I want to go back again to saying the three things about product that matter, right? UX design still matters, and it's going to matter more than ever when we start getting into multimodal agents and all of that. Like, how do you even design a UX interface where people are not even going to be looking maybe at a screen or speaking to it, and it's going to be multimodal, or it's going to be a completely visual interaction? Domain knowledge, deep and continuous user knowledge is a challenge, right? We saw how a traditional based LLM can learn about your user preferences, but you want that to be constant and be sort of like continuously updating based on what you're doing and your preferences. And then evaluations also become extremely complicated when you have long-running agents that are basically going to be going off for you and doing things for you on your own. So my next demo is an agent. So a recommendation agent. This is the interface for Agent Space. Agent Space is a tool from Google, Google Cloud, where you basically can design your own agents, connect it to a bunch of tools. You can also connect it to your backend databases, everything you have behind the scenes. But I designed an agent that's called Localify. And let's see what happens here. Okay, the first thing it says is, do you want me to recommend a cool local activity for you to do? Yes, let's do it. Okay. So it's, okay, great. To find events happening near you, I'll need to know your current location. Could you please tell me your city and state? Yes. I'm in Prague. Okay. Now, I'm not going to read what's doing. You can probably read it. It's doing a search. It's going off. It's searching for events in Prague. It's kind of like starting to do, it's structuring the queries. It's synthesizing the recommendations, refining the different possible choices, crafting the response. Oh, I know what happened. So, okay, I should have restarted I should have restarted. It already knows my taste because I tried it before before the presentation. I tried it to make sure it was working, and it didn't ask me the questions. The way this agent works, it will ask you questions about what you like and then recommend you local events that are happening. I'm not going to do it again because I already told it that I basically told it that I liked rock and jazz, and I liked music and cinema. Those are the two things that I told it. And because of that, it came back with these things: indie rock concert with the band Tornado Lua, an evening of live jazz, and independent drama film. So those are the 3 recommendations, and ask me which of this sounds most interesting to you. Actually, the jazz evening sounds interesting. There's no karaoke, so I'm going to go for the jazz evening. And then, okay, excellent choice. Would you like, yeah, sure, help me find tickets. And now, okay, so it's giving me a link, and it's saying you can buy your tickets here, and here they are. So yes, I'm getting the tickets for the evening of jazz, which is happening today or tomorrow. So this is an agent that has actually been designed by me, but the interesting thing, I'm going to show you how it looks. It's a very basic design. This is the design of the agent. You're an expert on local events. Your task is to recommend local events to users based on their taste. Follow these steps. Engage the user by adopting a friendly and helpful tone. Gather user preferences, which I skipped because I had done before, asking a kind of music, genres of movies, and then based on the answers, search for local events, and based on that, search for where to buy the tickets. All of this is a very basic prompt, which, by the way, fun fact, I didn't even write. I wrote a much worse prompt, and I click here on the help me write, and the LLM itself helped me sort of like improve it. And that's it. It took me literally 5 minutes to design this agent. And I didn't even connect it to any data sources and tools because I wanted to keep it simple. But here you could connect it to a bunch of tools. In fact, you can click here and connect it to your calendar, to your email, to Workday, to a bunch of stuff, including you can give it access to your credit card and say, instead of asking me giving me a link for the ticket, just go off and buy it yourself, right? That could be a little bit dangerous, but you can actually do that. And again, 10 minutes, you've designed an agent that can go off. In this case, very simple local events, but you could think about sort of like many more applications. And in fact, here you're seeing a more advanced version of this. This is called Project Mariner. This is also a tool for designing agents from Google, which has the added capability that the agent can browse the web for you. So it not only will access APIs and do queries and searches, it will actually take over a browser and be able to click on different parts and different webs and click through them. In this case, what it's doing, it's based on your resume, what you have in your Google Drive, it's going off and finding jobs that are good according to your resume, and it's going off to different websites, it's browsing, and it's telling you here the different steps that it's doing. It's scrolling down, looking for jobs that have software engineering in them. It's clicking, it's trying to map it to your resume. That is also sort of like a simple agentic flow, which the only added sort of like capability that it has is that it has browsing permits that you've given it to basically browse the web for you on your Chrome browser. Okay. Now, one of the important things to understand here is like this, LLMs are getting a lot of world knowledge. And I'm going to quickly project a clip here from Genie 3.
What you're seeing are not games or videos. They're worlds. Each one of these is an interactive environment generated by Genie 3, a new frontier for world models. With Genie 3, you can use natural language to generate a variety of worlds and explore them interactively, all with a single text prompt. Let's see what it's like to spend some time in a world. Genie 3 has real-time interactivity, meaning that the environment reacts to your movements and actions. You're not walking through a pre-built simulation. Everything you see here is being generated live as you explore it. And Genie 3 has world memory. That's why environments like this one stay consistent. World memory even carries over into your actions. For example, when I'm painting on this wall, my actions persist. I can look away and generate other parts of the world. But when I look back, the actions I took are still there. And Genie 3 enables promptable events, so you can add new events into your world on the fly. Something like another person, or transportation, or even something totally unexpected. You can use Genie to explore real-world physics and movement, and all kinds of unique environments. You can generate worlds with distinct geographies.
Okay, so Genie 3 and this kind of class of world models clearly sort of like open a window to sort of like generating, as I mentioned at the beginning, content on the fly, but not only content, but sort of like content that is being generated that is very realistic and has memory of itself. And that's a new kind of frontier that I think is coming. As I mentioned before, deep continuous user knowledge remains a challenge, right? And that is something that we're all working towards. And this is actually from a couple of months ago, where we're adding sort of like more understanding and more personalization into Gemini, so you don't need to always say, hey, remember I like jazz and I like independent cinema? It's like you can have sort of like a memory, persistent memory of yourself and your preferences. And of course, all of this is being driven by new research. These are papers from this year. Again, the 3 from Google, but the first one, user feedback alignment for LLM power exploration to enlarge recommendation systems. I think this one is ACL 2025. It's about using 2 different LLMs, one that is able to map and to optimize for the user preferences, and the other one for novelty. So this is about how to improve novelty in recommendations by using 2 different LLMs. The second one about serendipitous recommendation for multimodal LLMs, it's also about serendipity and novelty in recommendations, but instead of using a normal LLM, it's sort of like using features extracted from the videos to introduce that novelty into the recommendation. And then the final one, it's from RecSys from this year, so this one is presented in this conference, Balancing Fine-Tuning and RAC, a hybrid strategy for LLM and recommendation updates. This is an interesting one. Usually one way that you can introduce user preferences into an LLM is you doing fine-tuning, but fine-tuning is costly, particularly when you have millions of users. You are not going to fine-tune your model every day. In fact, this system that is online is fine-tuning once a month. And a way to sort of like introduce more constant updates is to combine it with RAC, retrieval augmented generation. So basically adding RAC a few times a week and then fine-tuning every month. This paper explains you how to combine those 2 things. And I know I'm getting over time and there's probably a lot of questions. So I'm going to finish with the conclusion here. This is like the second, maybe third time we're revisiting the recommender problem, right? It's a journey from clicks into conversations. And we started with trying to predict stars and then clicks. And now we're shifting to sort of like long-running conversation, agentic systems, and interaction with the users. I think agents are the future of discovery, and we're all going to have agents that are going to be discovering things for us in the background and coming back to us with sort of like novel things to engage with. And the personalization paradox, like LLMs have a lot of world knowledge, but it's still hard to introduce the knowledge about us. And how to do that is sort of going to be key for research in the next few years. The new evaluation frontier, as I mentioned, it's very hard to evaluate these approaches, particularly when they're long running, when they have sort of like all these different aspects that are coming in. And I think the ultimate prize will be this, maybe this kind of media of one, of like when you're going to have sort of like content that is not only discovered for you, but it's also created for you on the fly based on what you prefer and what you want at that point. So with that, I have a link here where you can find all the references in the talk are listed and linked there, and I will post the slides after the talk. And the last thing I will say, just as karaoke is a big thing in this conference, it's always been Morning runs are also a big thing. So tomorrow, Alan here has organized a run at 7 a.m. So rain or shine, we'll meet there. Thank you.
Thank you for the exciting talk. Because of your last bullet point, I want to ask to you some question, which is like, would you rather recommend items in your catalog or generate a new unique item to everyone? Like pros and cons of...
Yeah, I think it's an important question, and it raises a lot of even social aspects, right? So culture is about sharing sort of like the same artifacts and being able to connect to them and relate to them. So when I talk about personalized media generated for a single person, I also have to wonder, is that going to be good culturally? Are we going to lose the ability to talk about the Netflix show you watched last night? Because like, what are you talking about? That Netflix show doesn't exist for me, right? Because it's been created and generated on the fly. I think there has to be a good balance between those two aspects. But I do think that sort of like the being able to share culturally sort of like the same kind of content is important. But maybe what will happen is I will get a personalized show that has been designed only for me, and I will share it with you, and I'll send you a link like, hey, look at this show, and then that will go viral. I don't know. Things like that might be start to happen.
This dynamic interaction with LLMs changes the way users are exposed to recommendations. Given your experience, are there evidences that users would prefer to invest time in a potentially long conversation with an LLM rather than being exposed to the classic passive recommendations?
Yeah, that is a very, very deep question. And I think the answer is not simple. There's clearly a tension, and there's almost a divide in the way the world is going from sort of like the world of sort of like TikTok, give me recommendations on a continuous role that I don't even have to think about and I just can click. But there's also the very important trend that chat applications like ChatGPT and so on have become some of the fastest adopted consumer products, I mean, the fastest in the history, right? So when I hear people say, oh no, they don't want to think, they don't want to chat, they just want to click on one thing, I do have a very important counterexample. And I think we're all seeing a lot of engagement with sort of like longer form conversation. So I think the reality is there's different forms of engagement, and there's different times and different moments, and maybe even different preferences for people at different moments in time or in their life. And we also have to sort of like be able to combine them in a wise way, right? There will be the moment where I'm just brain dead, going after work home, and I just don't even want to think about it. It's like, give me something and play. But there are other moments where I'm really engaged and I want to invest in sort of like finding that right content. Also, it does depend on what is the ROI of my investment, right? Maybe if I'm going to just watch a 30-second clip, it doesn't really matter, just give me anything. If I'm going to invest in watching or reading my next book, which is going to take me a few hours, I want to be sure, or I want to make sure that it's a better recommendation.
Thanks so much for the great keynote. I had some question like you show like how we can use agents for doing recommendations, and I think it's fantastic, very good application. And you also show how deep generation works with Genie, fantastic work. But I was wondering, what is your like take, and how could this be integrated to do recommender systems, and yeah, what's your perspective about that?
Yeah, so my perspective about that is that I think the AI revolution, so to speak, that we're in the middle of sort of like experiencing right now is going to impact everything, starting from the algorithm to the UX to the product. So it doesn't really make sense to address those things separately. If you're just going to be changing the algorithm, but just putting it into the same product you had without changing the UX, that's not going to work. But by the way, that was the exact same thing before. if you had a product that was based on the 5 stars and you tried a different algorithm, things didn't work because you had the 5 stars. But then when you change things together, the magic happened. So this is going to happen right now, but in a much bigger way. As I mentioned, we're going to have multimodality coming in. I will say, like, I don't even know, like, the phone, is it going to be a thing in 5 years? I'm literally not sure. We might be using other devices. I mean, I'm using AI glasses and I like them. Maybe that's a form factor that is going to come in. We're going to be talking instead of typing more, probably. So the point here, it's not only about saying, oh, I have all this product. How do I introduce LLMs into this little corner? That, well, I've tried too, by the way. And it usually doesn't work, right? You need to think holistically about how you design your end-to-end, your UX, your new product flow, your feedback from the user, and the algorithm goes hand in hand.
Awesome. Thank you for the great talk. I do have a question about the agents as well. Because right now agents do a lot of web search, right? So they consume content created by people. But if people know that their content is no longer read by other people and nobody clicks on the little ads to earn some money, where's the incentive for humans to keep creating content? Or do we think there is a near future where just agents create and consume content and the human just is the consumer in the end?
No, it's a very important question, and one that I think there's not a very clear answer yet. I will say there's many efforts in creating sort of collaborations and contributing with content creators. I mean, we have a lot of those at Google. For example, in YouTube, it's a clear one, right? YouTube, there's a lot of YouTube creators. These creators are also using synthetic tools now to help them, and AI tools to create content. I think at the end of the day, AI is going to democratize the creation of content even more, and it's not going to replace, right? I think there's been a lot of revolutions in the content creation industry in our history, and at some point, I think movie makers also worried, right? Like, what do you mean? Anyone can upload a video on YouTube and get millions of views? Well, yes. But at the same time, did that completely kill sort of like cinema and movies? No, of course not. So there's going to be sort of like a combination of different aspects. But I do think it's very important for to continue encouraging the human creativity side. In fact, I would say that's one of the important aspects of AI. I think it's going to be key to introduce, to encourage that aspect in a way that sort of like every human can be more creative than before, not the other way around.